Lesson 10, Distribution Table. A distribution table displays all of the various data values in one column, along with an associated parameter or statistic of interest in another column. So to begin a construction of a distribution table, you first draw a rectangle divided into rows and columns. And then, as with all graphs, a descriptive title appears at the top. It's also important that each column of the table be clearly labeled. The first column of the table displays the data, so the data must be clearly labeled, followed by an organized, clearly displayed list of all the data values. Additional column is labeled as the statistic of interest. If more than one statistic is required for the problem, then additional columns can be added to the table. Distribution tables can be constructed using data of any type, qualitative or quantitative, continuous or discrete, and at every level of measurement, nominal, ordinal, interval, or ratio. Distribution tables describe how the parameter or statistic of interest is allocated or distributed amongst all of the various data values. There are several parameters or statistics available to choose from for inclusion in a distribution table. In this lesson, we will learn to determine two such results: the frequency and the proportion. The frequency is a count that represents the number of instances a particular data value occurs in the population or sample. The frequency of the particular data value x is denoted by the symbol f sub x. For instance, in the sample of milk chocolate plain M&Ms shown here, if we wanted to determine the frequency of green M&Ms, we would just need to count the number of green M&Ms in the sample. 1, 2, 3. Therefore, the frequency of green M&Ms in the sample is 3. Thus, f sub green equals 3. The frequency describes exactly how many of that particular data value appear in the population or sample. When it was determined that there were 3 green M&Ms in the previous sample, all we learned was how frequently green M&Ms occurred in that sample. The frequency does not provide us sufficient information to determine if this was a small, medium, or large amount of M&Ms. In some situations, 3 would be considered small. In other situations, 3 would be considered large. You see, size is a relative notion. For instance, 3 green M&Ms would be considered a relatively small amount of M&Ms to be eaten by an elephant, whereas the very same 3 M&Ms would be considered a relatively large amount of M&Ms to be eaten by an ant. If it is important to the issue under investigation to describe the relative size of various data values, the proportion is the appropriate parameter or statistic to include in a distribution table. The proportion is a relative frequency that compares the frequency of a particular data value to the overall population size or total sample size. The proportion is calculated by dividing the frequency by the total of all the frequencies. The population proportion for a particular data value x is denoted by the symbol p sub x, and it is calculated by taking the frequency of that population value and dividing it by the total population size. The sample proportion for a particular data value x is denoted by the symbol p hat sub x, which is calculated by taking the frequency of that sample value and dividing it by the total sample size. For instance, in the sample of milk chocolate plain M&Ms shown here, we've already determined that the frequency of green M&Ms was 3 by counting 1, 2, 3. We can turn this frequency of green M&Ms into the proportion of green M&Ms by dividing the frequency by the total sample size. So to do this, we count the total number of M&Ms in this sample, which is 24. So n, the sample size, is 24. Therefore, to calculate the proportion of green M&Ms in this sample, we take the frequency, 3, and divide by the total sample size, 24. 3 divided by 24 also equals 0.125 decimal. And multiplying this decimal value by 100%, we also get an equivalent value of 12.5%. Therefore, p hat sub green, that is the proportion of green M&Ms in the sample, is either 3 out of 24, 0.125 decimal, or 12.5%. Results of proportion calculations can be represented as a fraction, decimal, or percent. It is customary to express the final decimal result to at least the 1,000th place value, that is, 3 places after the decimal. This enables the final percentage result to be expressed to at least the 1/10 of a percent place value. Data values can be listed in the distribution table either individually or in groups. Either way, the approach used to list the data values must consider the number of rows required to display all of the various data values. The number of rows in a distribution table must be reasonable in order to clearly reveal the distribution of the data. Too many rows can make the table difficult to decipher and typically dilutes the essential elements of the distribution. Too few rows can overly condense the table, which quite often conceals crucial details. In general, a reasonable number of rows to display in a distribution table ranges somewhere from 4 on the low side up to 24 on the high side. Each and every data value must be included in the distribution table and belong to one and only one of the rows. The following examples will help illustrate how to construct distribution tables.